Hello dear students, today we are going to discuss about acceleration. Okay, so at the end of the lesson you will be able to define acceleration. Also you will be able to draw and interpret velocity time graph, and also you will be able to calculate displacement from velocity time graph. Okay, so in last class we had discussed about speed and velocity. Okay, what is speed? Speed is nothing but distance over time. That is change in distance with respect to time. That is speed. Okay. And it is a scalar quantity. Here we are not specifying direction. Isn't it? Now, what about velocity? Velocity is nothing but displacement over time. Change in displacement over time. Okay, or you can say the rate of change of displacement. So displacement is nothing but the straight line, shortest straight line distance from initial and final position is the displacement in a particular direction. Okay, for displacement we are specifying the direction. For distance we are not specifying the direction. Distance with respect to time is speed, and displacement with respect to time is velocity. That's the difference. And velocity is a vector quantity, speed is a scalar quantity. Okay, you should remember these things. Okay, so shall we move? Now we can discuss about acceleration. Okay, before that I will show you a image. Okay, in this pictures you can see a car moving at a speed 40 kilometer per hour at 8:45 a.m. Okay, and in the second figure you can see this is brake, and other one is acceleration. Accelerator. When we press the accelerator, the speed increases, isn't it? So at 9 a.m. the speedometer records the speed as 45 kilometer per hour. Okay, so here speed is increasing, or we can say it is accelerating. Okay, so in this class we are going to discuss about acceleration in detail. Okay, so shall we go? What is acceleration? How we can define acceleration? Acceleration is nothing but rate of change of velocity. Change in velocity with respect to time, that is acceleration. It is nothing but speeding up or slowing down. What is the symbol of acceleration? A. Okay, what is the unit of acceleration? Meter per second square. Now, you should know two terms, that is average acceleration and instantaneous acceleration. Average acceleration can be defined as the ratio of the total change in velocity to the total time interval. Look here, A equal to delta V by delta T. We usually represent average acceleration. Acceleration is nothing but change in velocity with respect to time. Okay, change in with respect to total time. Okay, what is delta V here? This sign is called delta. Delta V by delta T. What is delta V? That is change. Change means final velocity minus initial velocity. Vf is nothing but final velocity and Vi is initial velocity. Okay, so change in velocity by time will give you acceleration. Now next is instantaneous acceleration. Instantaneous acceleration is nothing but rate of change of velocity at a particular instant. Okay, understood? So far we have discussed acceleration. Acceleration is the rate of change of velocity, and it is unit is meter per second square. Average velocity is nothing but ratio of total change in velocity to the total time interval. Understood? Okay. Now we can discuss velocity time graph. In velocity time graph, time is plotted in the x-axis and velocity is plotted in the y-axis. Okay. So in the previous session, we understood that what is gradient? Gradient is change in y-axis with respect to x-axis. So if we do delta x by delta y by delta x, we will get gradient. Here what is in the y-axis? Y-axis it is velocity, and in x-axis it is time. So gradient is change in velocity by change in time, that is delta v divided by delta t. Okay, so here if I find the area, I have a graph like this. If I have a graph like this, I need to find the area under this graph. So draw the triangle. So what is the area? That is here. What is the area of triangle? Area of triangle is half base into height, isn't it? Half base into height. Here base is time and velocity is height. So what is velocity into time? That is displacement. So area under the graph will give you distance or displacement. If it is speed time graph, we will get the distance, and if it is velocity time graph, we will get displacement. Okay, understood? So area under the velocity time graph is distance. Very important. Now let us discuss some more graphs in detail. Okay. So these are the different graphs related to velocity time graph. In the first graph, you can see a straight line with positive slope that shows constant acceleration. Okay. So that means what is constant acceleration? Here you can see at when time increasing, velocity is increasing constantly. That means the velocity increases uniformly over a time. Okay. Now, what about the second graph? Here, the greater the slope, the greater the acceleration. Here this has greater slope, so high acceleration for this. Let us name, okay, here this as A. Line A has a highest acceleration than line B. Now, what about the third graph? Here, if we closely analyze, you can see as time increasing, velocity is not changing, it is constant. That means acceleration is 0. Okay. Now, in the fourth graph, here velocity, here a negative slopes. Here negative slope. For this line we will get a negative slope. That means acceleration is negative. Acceleration is negative means velocity is decreasing over a time. And in the last graph, The slope, you can see the slope is changing. That means acceleration is changing. That means the curved graph indicates the acceleration is changing. That represents non-uniform acceleration. Okay, non-uniform acceleration. Understood? Okay. So if you want to find the area under this graph, just draw the tangent. You will get the if you draw the tangent, you will get the direction of acceleration. Okay. Now next is how to calculate distance from velocity time graph. Here there are two graphs. In the first graph, what is the distance? Here, what is the length area of a rectangle? Area of rectangle is length times breadth. What is the length? Length is 15 and breadth is 20. So what will be the area? Area is 300 meter. Now we can find the distance from second graph. Okay, so area under the graph, here the area is nothing but a triangle, that is half base into height. What is base? It is 5, half times 5 times half times 5 times 10. That means 25 meter is the displacement of the second graph. Understood? Okay. So